Hello and welcome to this video that goes through the AQA Certificate in Further Maths Level 2 Specimen Paper 2 paper. We're going to go through questions 6 to 10 in this video. So for question 6 we have x, y and z are three quantities such that x to ratio y is 3 to 2 and y to z is 5 to 4. He wants us to express the ratio x to z in its simplest form. So here the first thing we notice is that the common sort of letter between these two ratios is y, and again for any question like this you'll always have a common sort of one that we have. So we start off, we have x to y is 3 to 2 and y to z is 5 to 4. And the goal here is to try and get the y's equal to each other, because then we can almost cancel out the y's, or not cancel them out, but essentially we can link the two together. So our y's are our linking point between the two ratios. So for here we want to find the lowest common multiple of 5 and 2 so that we can multiply it. So here I think we're just going to multiply by each other, so essentially by both the left one by 5. So if we do the left one by 5, we get 5 times 3 is 15, and we get 2 times 5 is 10. And on the right hand side we're going to times it by 2. So here it becomes 5 times 2 is 10, and 4 times 2 is 8. So now we can link the two together because we have a y term that is the same in both ratios. So we've got 15 to 10 to 8. And from here we can always not cancel it out, but we can ignore the y because we're only interested in x to z. So therefore x to z is going to be 15 to 8. And then from here this can't be simplified any further, so our answer is going to be 15 to 8. Again, make sure that you match your ratio to what the question is looking for, so make sure you don't write 8 to 15, you write 15 to 8. And that is your answer for question 6. Question 7, ABCD is a quadrilateral. Prove that AB is parallel to DC. So the first thing that I'd want to do here is probably find what x is. I know AB and DC are parallel, but I don't really have any information here that can help me. Most likely what I'm thinking with the parallel lines is probably using the parallel angle rules, but I also know that all the angles inside of here add up to 360, so I can easily find what my x value is by simply adding up my angles, so x plus 4x plus 3x plus 2x, and saying that's equal to 360. From here, so x plus 4x is 5x, and then 3x plus 2x is also 5x, is 360, so therefore 10x is equal to 360, so divide both sides by 10, we get x is equal to 36. And then from here, I can then think about some of my angle rules to prove that AB is parallel to DC. So I can't really prove it in any other way apart from showing that the angles, apart from showing some of the angle rules, the parallel angle rules that I have. So for example, I could use some of the rules. The main rule that I think I'm going to use here is corresponding angles allied angles rules, which is this one, which is that if we've got A and B here, so A plus B is equal to 180 degrees. So I can test this out, so I could do 4 times 36, which is equal to so 4 times 36 is equal to 144, and I know x is equal to 36, so 144 plus 36 is 180. So that shows that 4x plus x is equal to 180, and I can test the same thing out here, 3x plus 2x, so 3 times 36 plus 2 times 36, and plug that in your calculator, which gives you again 180. So again you've proven that 3x plus 2x is equal to 180. So therefore we can say that the interior angles, or allied angles, which is what these are called, add up to 180 degrees. So therefore the lines DC and AB must be parallel. Again, this is a sort of classic sort of question where it's not obvious from the start where you need to go from this, but if it asks for parallel, think about, and you're given angles, think that, again, you can use the parallel angle rules. It's very much similar to like a circle theorems type of question in terms of like, you've got a circle and you've got some lines, so think like, oh, what kind of rules do I need to use here? So again, it may not be something that comes easily to mind. Hopefully now you've seen the question, if this comes up in your exam, you will have some idea of where to start. Again, you could always pick up easy marks by knowing various facts. So the quadrilateral one, again, you could pick up an easy 2 marks here. So you've got 2/5 of the question already by just finding x equals 36. So even if you couldn't work out or couldn't figure out what to do next, easy to pick up the marks by just adding up angles and trying to solve them algebraically. Question 8, the function is defined as f of x equals 1 over x squared minus 3x minus 10. X has domain all x except x equals a and x equals b. Work out a and b. Okay, so for this one here, if we have a 1 over, so a function that is 1 over x, so a function that is equal to 1 over some f of x function. So we just do 1 over x to start with, just to show what it's like. 1 over x has a function that looks like this. So we can see here that in terms of a domain, now remember the domain is essentially the allowable x values. We can see that the domain here we don't have any values. It's impossible to have any values for that function when x is equal to 0. So we can see here that whenever the denominator is equal to 0, that will give us an asymptote. That means that we cannot have a solution for that value. So for here, again, we're really looking for when we have in domain 1 over it, 1 over x is sort of an impossible function. It goes off to infinity. So therefore, what we can do is we can say, well, let's look at our denominator in our question, x squared minus 3x minus 10, and make that equal to 0. From here, we can factorize our equation, so it's going to be x minus 5, x plus 2 is equal to 0. So therefore that's going to be when x is equal to 5 and x is equal to minus 2. And this actually gives us our result directly, where a is equal to 5 and b is equal to minus 2, or the other way around is completely fine. Because here if you plugged any of those numbers in, so you can always test this on your calculator, so when you're checking your work make sure that you do test. So here you're going to do 5 squared minus 3 times 5 minus 10. And here you will get on your calculator an impossible answer. So that shows you that again that the f of x cannot exist for when x equals 5, and then you can plug in x equals minus 2 and test your answer, and you should get another answer of 1 over 0 or an error on your calculator which shows that f of x cannot also exist for that one. So therefore you have shown that apart from a and b, well, you found a and b essentially. Question 9a, expand and simplify x minus 5 times x squared plus 4x minus 2. This one very straightforward, simple algebraic type of question, multiplication question. Just take it nice and slow and steady. So here we start with x times x squared, which is x cubed. Then we do x times 4x, so plus 4x squared. And then we do x times minus 2, which is minus 2x. Then the next term, again, watch out for the sign here. It's minus 5 times x squared, in a different colour. So minus 5 times x squared is minus 5x squared. Then minus 5 times 4 is minus 20x. And minus 5 times minus 2 is plus 10. Again, if you need to write out individually each multiplication, that's fine. It's an easy 4 marks to get, so it's well worth your time writing everything out. Then we're going to collect like terms, so it's x cubed is the only cubic term. We've got 4x squared minus 5x squared, which is minus x squared. We've got minus 2x minus 20x, so minus 22x, and then we have plus 10. And that gives you your answer, x cubed minus x squared minus 22x plus 10. A nice easy 4 mark question. For part B, factorize fully x squared minus 16 minus x minus 4, 3x plus 5. So from here, I would, if we want to factorize it fully, we want to expand out our terms and get a 1 equation, because we're trying to, factorize it fully. So I would say that we would want to First of all, let's expand this out. If we're trying to factorise, we've got x squared minus 16. So let's expand this out so it's got the factors here. So if we've got x squared minus 16, this is the difference of two squares. So essentially it's going to be x, and then the square root of 16 is 4. So it's going to be x plus 4, x minus 4, minus x minus 4, 3x plus 5. Now, it wants us to factorise fully, and we can see here that in both of our terms we've got an x minus 4. So we're going to pull that out of our equation. So it's going to become x minus 4 bracket x plus 4 minus 3x plus 5. Again, put a bracket around each of them if you want to, just so that you don't lose any of the signs. So here we know that one of our factors is going to be x minus 4. For the second one, we're going to expand this equation out. So we're going to collect terms essentially. So it's going to be x minus 3x is minus 2x, and 4 minus 5 is going to be minus 1. And that gives us our final term, x minus 4 and minus 2x minus 1. And we can write that as our final one. We are happy. We don't need to simplify this. We don't need to take out any negative sign, etc. We can just leave the negative sign in there, because that's all the question is asking for, is a fully factorized form which can accept two negatives. Again, if you wanted to, you can take the negative out if you make that choice. So you get x negative x minus 4 and then 2x plus 1. That is perfectly correct as well. And that gives you 4 marks. The last question of this video is going to look at question 10. Here are a parallelogram and an isosceles triangle. The area of the triangle is greater than the area of the parallelogram. Show that x squared minus 4x is greater than 0. Okay, so the first thing you do is always check your formula, look to see if you have the area of the trapezium, or parallelogram, or the triangle, and you don't have it. So again, it's something that's worthwhile remembering. This one is the area of a parallelogram. So the first thing here is that we find the area. So the area of the parallelogram is simply equal to the base times the height. So for the parallelogram is equal to base times height, which is equal to x plus 4 times x. For the triangle, we can therefore say that the triangle is base times height, based on an isosceles triangle. So an isosceles triangle here, this is 90 degrees, and this angle here must be x, and this angle here is also x, which means that this side here must be the same. Okay, we also know that these will be 45 since it's a right angle triangle, but the key thing here is that this is isosceles, so that means the other two angles must equal the same, cannot equal this angle because this is 90 degrees, and therefore we know that this side and then the other side that links it with the angle that we don't, well, which is 90 degrees, that must be 2x. So therefore we can use the area of the triangle, which is equal to half. So for a right angle triangle, which is half times base times height, which is equal to half times 2x times 2x, which is equal to 2 times 2 is 4, divided by 2 is 2. It's going to be 2x squared. Then from here we want to say, so it says that the area of the triangle is greater than the area of the parallelogram, so that means that 2x squared must be bigger than x plus 4. From here we can expand the bracket on the right hand side, so it's 2x squared is greater than x squared plus 4x, and then move everything over to the left hand side. So 2x squared minus x squared is x squared, and then 0 minus 4x. So we get minus 4x is greater than 0, and that's your answer for part A. For part B, work out the least integer value for x. So then from here we're going to say that x squared minus 4x is greater than 0. We're going to take out a factor of x. It's going to be x minus 4 is greater than 0. So here we know that if it's, so from here you should always, at this point when it's an inequality with a squared term, we should always consider drawing a graph. So here we know that x is equal to 0 and x minus 4 equals 0, so x equals 4. So that allows us then to draw our graph when x is 0. So this is 0 and this is 4, and we can just sketch a quadratic. From here, it means that we're finding when it's greater than 0. So when it's greater than 0, we've got the terms when x is less than 0, and we've got the terms when x is greater than 4. Now the least integer value for x, the first thing we're going to look at here is the x is less than 0. Always consider your situation here. Yes, you could say the least integer for x is probably minus infinity. However, you cannot have a negative x because that will give you a negative value for your length. So therefore we can rule this out straight away because it doesn't fit into our situation. It would also mean you'd have no height in your parallelogram. So therefore we have to look at this one now. It cannot be 4 because it's not equal to, so the following integer from 4 is equal to 5. And that is how you work out your least integer value for x. That brings to the end of questions 6 to 10 of this video. If you have any further questions, please let me know.